Brake actuation in air disc brakes begins with air entering the brake chamber actuator. The pneumatic force of the air in the chamber actuator moves the push rod into the top of the lever. The lever pivots forward and rolls up on the eccentric bearing. When the lever pivots, it pushes the bridge forward. As the bridge moves, it compresses the return spring into the caliper holding the inside brake pad against the rotor. This causes the caliper to push the outside brake pad against the other side of the rotor. Clamping forces of the brake pads onto the rotor generate the braking force for the wheel. Brake release exhausts air from the brake actuator chamber through the supply port. Exhausted air causes the push rod to retract, removing pressure from the lever and bridge. This causes the return spring to relax and extend. The return spring pushes the bridge and lever back. The calipers release, maintaining the running clearance between the pads and rotor. After a number of brake applications, both the brake pads and the rotor wear down and become thinner due to friction erosion. A device within the air disc brake automatically adjusts for this change in clearance between the thinning pads and thinning rotor. Here we can see the rotor, bridge, return spring, and brake pads. Within the bridge, we can see the threaded tube, adjuster unit, and turning device that are part of the automatic brake adjuster. The two threaded tubes lead to the tappet and boot assembly. The tappet pushes the caliper the distance to make up for the pad wear of each brake application. Every time the brake is actuated, the adjuster turns the threaded tube by the amount necessary to maintain a clearance between 0.7 and 1.2 millimeters between the brake pad and rotor. A clearance outside of 0.7 to 1.2 millimeters results in poor braking performance.